Welcome to this episode of Hela Mchangani. Now, you're probably used to the conventional dome system of producing biogas, but this week we'll be talking to Dominic Kahumbu, who will be telling us of an easier technology of producing biogas with his company, Flexi Biogas. Let's hear what he has to say. Thank you, Dominic, for joining us on Hela Mchangani. We're definitely eager to learn from you. Flexi Biogas. Tell us just a brief of what Flexi Biogas is.
Well, Flexi Biogas is a new technology. We developed it over the last about 4 years. But go on. After looking at the conventional technologies that are available in biogas, they were developed almost 3 centuries ago. And what they knew back then about biogas was very limited, 300 years ago. So the technology they developed, I mean, don't get me wrong, they do deserve, Oscar awards, or not Oscar awards, what do you call it? Environmental awards and what have you for absolute genius of their time. Yeah. But now we know so much more about biogas that the conventional technologies are still the same. So we have really worked on improving the former technologies. So our system now, for instance, it's above ground. Underground is cold, so temperature is one of the key catalysts to biogas production. So our system is above the ground and it's housed in a greenhouse. So we are achieving much higher temperatures, which means that we're achieving far
Mm-hmm.
higher efficiency rates in biogas digestion and methane production.
Yeah. How far have you gone with this technology in terms of reaching to people, teaching them how to use this one in comparison to the other one that most people are used to and know about?
I would say we're very new with this technology. We're only been about 2.5 to 3 years in actual production. Before that, we were more R&D. We were testing the systems, giving them to the users, letting them play with it, correcting their complaint. Everything they would complain about, we would improve the system, till we got the final product that you can see behind us.
And how has the response been from people?
A bit slow in Kenya, I must admit.
Yes.
We have, over 3 years, we have put in quite a number of systems. We're probably hitting close to 1,000 systems in Kenya. Other countries like Rwanda have fully adopted the technology because of the efficiency. You only need 1 cow to produce all the gas you need for domestic use. Yeah. Conventional systems, you need 5 cows.
Oh, wow.
Yeah, so the efficiency level is so high. So in Rwanda, their zero grazing poverty alleviation program is a 1 cow program. Yeah. And of course, the dome system cannot meet the dung from 1 cow cannot meet the domestic use. Yeah. But our system does. So the Rwanda government has actually adopted this almost fully into their programs. So we're rolling it out there. They're adopting the technology much faster than here. They only saw 10 systems and they put out international tenders for the systems. So in Kenya, it's been a bit of a struggle, trying to get noticed, if you may. Yeah. We've been on the shows, we've been in the media. We are what you call bootstrapping. We're selling, one buyer tells another person, it's through hearsay, it's through Facebook. We're trying to get into the national biogas and the poverty alleviation national programs. But it is a bit of a challenge.
Why do you think Kenyans are not really responding, that fast compared probably to Rwanda?
Partially, I would say, partially it's us. We haven't had the exposure. Yeah. We're a small company. We don't have the big money to do a big national campaign, roll out advertising in TV and what have you. The media has been very good. Okay. And also, I think partially because, people are resistant to change. So they know the dome system. So it's more a matter of just time before I think people will get themselves familiarized with the technology, and then adoption should pick up. It's picking up, it has picked up over the last 3 years. So it is on an increase, Of course, we would like it to be much faster than we're going, but you know, that's the way it is.
Yeah. Okay. As I was doing my research, I noticed you don't necessarily have to have a cow. Could you explain how else it could work?
Okay, because of the design of the system, conventional systems, you must have, if I may say, the cleanest poop. Cow dung is smooth. It is it's ready processed. You know, it's ready for a biogas digester. In fact, the first digesters will only run on cow dung, somewhat pig dung, but certainly won't run on chicken dung or anything else. Our systems, they don't mind what you feed them. We normally start the systems using cow dung just to get the correct culture into the system. But then you can switch. You can run on chicken dung, you can run on pig dung, human dung, dog poop. But not only that, the higher the calorific value of the feed you feed a digester, the higher the gas production. So we also promote with our farmers or our customers of the system to grow castor, which is considered a weed or a waste plant. Okay. But it's extremely high in oil. So vegetable oil will produce 50 to 60 times more gas than will cow dung. So if you mix in these oil plants, or restaurant waste is also very heavy in oil, mix it in with your dung or whatever other waste you're feeding into the system, and your gas production just rockets.
Okay. And how exactly does it work? I know you will show us later, but compared to the other system where I think you need to dig and you need a lot of cow dung, how exactly does this other one work? When you mix, you know, the ratio, what amount of waste do you need? Yes.
Okay, from implementation, from installation, for instance, we just had a customer this morning, the ladies who you met just now. She has paid by bank transfer, so telephone technology is very doing very well for the technology. She's carrying the system today. We will send a technician tomorrow. Within 3 hours tomorrow, her system will be installed.
Wow.
It takes 3 hours to install.
That's amazing.
Yeah. Within 3 days, it will have started gassing up. Within 7 days, she'll be cooking. Within 10 to 12 days, it'll be running at optimum. Okay. And she'll be off all her other forms of cooking fuel. Yeah. The system, like I said, it installs in 3 hours because it's surface mounted. It's so compact, it will fit onto a motorcycle. So we can get it into, we often transport it on bicycles and borders. Okay. So we can get it into the most remote corners of the planet. Yeah. It installs in 3 hours. The only technical component to the installation is the leveling of the ground. The ground has to be absolutely flat. Okay. Yeah. It's a cross-flow methodology, so you feed it from one end and it overflows from the other. So you're never mixing exiting feed or exiting substrate with substrate that's going in, exactly. Okay. So the dome system, one of its biggest inefficiencies is exactly that. They are designed to have an agitation methodology, which is the mixing, the up and down of the expansion chamber, which stirs the main drum, if you may, of the substrate. So what you're feeding in today is getting mixed with what was in there yesterday and what was in there, a month ago. And if all of it is like one uniform mix, it will move across to the expansion chamber and overflow, which means that what you put in today and yesterday hasn't even had time to ferment and it's already overflowing. And
how many times do I have to feed in do I have to feed it in?
We recommend to be fed every day if you have access to the waste. Yeah. We'd like you just to get into a routine because people tend to say, tomorrow never comes. And people say, I'll do it tomorrow. I'll do it tomorrow. It looks like there's enough. I'll do it tomorrow. And then they start calling us and saying the system's not working. When in fact, it's just that somebody is not feeding the system. Yeah. Exactly. And that's one of the biggest common problems. So we tell the people, get into a routine, feed the system every day. If you don't have waste, get into a collection of waste. Feed it twice a week, even if you're feeding it once a week. Just make sure you don't miss. Get into your schedule and stick to your schedule. So the mixing ratio is 1 part, whatever it is you're feeding, whether it's vegetable waste or whether it's our dung. You mix at a ratio of 1:1 with water. Now, again, the water doesn't need to be clean. Everybody says, but it's very heavy on water. I don't have water because I come from a remote area. And we simply say, but don't you wash your vyombos in the kitchen? Don't you bathe? Don't you? And they're like, yeah, we do. So what do you do with that water? Well, we throw it out. We say, well, use it on the digester. Even if it's got soap in it, it doesn't matter. Soap is harmless to the digester. We don't promote the use of heavy detergent water, but the rinsing water that you use to rinse out your clothes after you've washed them in the soap, that water it's got so little detergent in it, it's not going to affect the microlife inside the digester.
If I'm a farmer, somewhere, and I want to start I want you to, put in place for me, how much will it cost me to start to get one?
Okay, we have 3 systems. Yeah. We have the small system, which is going at 46. Okay. That one is designed primarily as a cooking replacement, a cooking fuel. Mm-hmm. We pegged the system, the smaller system, on the cooking of maize and beans, or githeri. Yeah. We believe that once you've solved that githeri problem, you've solved Mama Mboga's problems. Yeah. You've solved all of them, because she will never, the dome system, a lot of people will always cook githeri on firewood, but cook the rest of the meals on the dome system. To me, you've added a problem to her, because now she's collecting firewood and she's dealing with a biogas digester. You're not alleviating the problems. Mm-hmm. So ours is a one-stop alleviation. So we designed our system to give you enough gas to do that. It will cook your food, all your food, and it will do all of your water necessary for a family of up to about 6 people. Wow. The next system is what we call the BG5, which will give you almost twice the amount of gas as the first one. It goes for 61,000. We find that people who use the smaller one wish they had the bigger one, because once they have all of that extra time, those 3 hours that they were spending collecting firewood, they now have 3 hours free every single day, but they don't have energy because the digester was only designed for cooking. Yeah. So they want a bigger one, because the more energy they have, the more productive they can be. Yeah. So we say that the lack of energy is the driver of poverty. So once you alleviate those 2 problems, time management and energy, and you've got all of your surplus fertilizer coming from the system, a bit of education on value addition to crops, and you are out of poverty. The third system is 76,000. That system will produce twice the amount of gas as the previous one of the BG5. That gas now can be used to run machinery. So you can run a generator. We have a specialized specialized generator. We call it a bio-DC genset, which basically produces high voltage, a 3 kilowatt generator, which you would use to run your shaft cutter. You could use it to run your milking machine. You could use it to run your water and all of these agricultural tools. Yeah. At the same time, it's running an alternator that's backing up power in batteries. Mm-hmm. So you only need to run the generator for the limited amount of time you need to do those heavy chores. Maybe half an hour or 45 minutes or an hour in a day. Yeah.
About that, how often should one feed? Did I ask that? How often should one feed it, so that it will be enough, say, for one day? Or for 2 days or a week?
What you want to do is you want to make sure that the gas, if you look at the digester, you want to make sure that it's between your knee and your thigh. We advise the farmers to feed it every morning. Get into a routine. Don't wait for tomorrow. Yes. But once the users get used to the system, many a time they just feed it when it looks low, because it's like a pet animal. The more you feed it and the more water you give it, the higher the production. So they get in tune with their system, much rather than telling us how to operate it. They get used to it, and then they talk to each other as well. Yeah. So they share ideas, and they're putting in different things into their systems, and we're getting a lot of feedback from them as well. Yeah.
We'll take a short break, but when we come back, Dominic will be showing us a bit of the process of how the Flexi Biogas works, and also some of the benefits of the biogas. No training.
No, the first time I saw biogas,
Yeah.
I was about 10. I saw the blue flame,
Okay.
and it was stunning. And then I was lifted up, when I asked where is the gas coming from, I was lifted up and put on top of what's called a floating dome system.
Yeah.
And it was like a big drum floating on this liquid. I can still remember very vividly looking at the flame and looking at this thing I was standing on, thinking, this isn't going to happen. You know, they just didn't make sense. A small flame and this monstrosity of a construction.
Yeah.
It just didn't click that this would ever be, you know, would make sense. And so I've been toying with biogas ever since. I was, you know, putting cups inside cups, tins inside tins, drums inside drums. I was inverting, you know, big rotomold plastic tanks. I was given a challenge by my sister Paula, who is at the time she was the chairperson of FONAP, the Friends of Nairobi National Park. She's a conservationist. Yeah. She actually is running the Hands Off Our Elephants campaign at the moment. Okay.
Yeah.
And she gave me the challenge to find a solution for the Maasai community living behind Nairobi National Park, who are cutting down the trees. And it's being turned into charcoal. And it's being sold in Kitengela. So they were trying to win the hearts of these Maasais by sensitizing them and providing them with reasons not to cut down the trees, giving them, well, proposing to them solutions and how to generate income from their land, as opposed to, you know, selling it up and cutting down the trees and destroying it. And so I proposed flexible biogas, portable flexible biogas systems. And basically, Flexi Biogas was born. We put the first system in Masai Mara. I believe the first system is still running. The model then has completely changed, because what we did was, the Maasais was very hard for them to uptake. Yeah. Their biggest concern was what are our women going to do if they don't collect firewood? Yes. Yeah. So, but the people in Machakos, the people in Central, the people in Rift Valley, they have virtually finished their trees. Yeah. Firewood is extremely hard to come by. Nyanza is even worse. They are cooking with maize cobs and maize stalks. So they're now uptaking the technology. Yeah. And yeah, the first users, the first models had technical issues with them. The people, when you come up with a new design of anything, don't expect the people to do with it what you think should be done with it, because they will figure out how to make it stop working, how to break it. And so this went on for about a year or 2 years. We were replacing systems, fixing all the issues with the users, until it got to the stage where there was nothing more to fix. The users were happy. There was no complaints, no issues with the system. And so that's when it became, we standardized the systems, we standardized the components, we set up like an assembly line. The volume started picking up, and of course NGOs and other organizations that wanted to buy and purchase systems, we needed then to formalize and now become an official company, a registered company. And we basically moved from there. And we were claiming on our Facebook that we had a system that could produce enough gas for the domestic homestead with the dung from one cow. Yeah. This is not achievable with any other biogas system. They were like, prove it. We joke with them and say they actually came out here to prove it can't. Not to prove it can, but to prove it can't. Yeah. So they put in 2 pilots, 10 systems in Nakuru and 10 systems in Rwanda, which they monitored independently. And within 3 months, Rwanda had completely bought in. They said, this is the technology we're going to use. And IFAD has since then been supporting us in, because of the proof that it does work, took us to India. The India IIT, the Indian Institute for Technology, who we are now partnering with also, also in the beginning had wrote off the technology. They said, been there, done that, can't work. And we said, stop saying it can't, let's put one in for you and then tell us. And within 3-4 months, they did a 360 and said, this works. So they've also endorsed the system. Okay. So we're looking at scaling up there also. So IFAD are very instrumental in that. They're helping us to push us into large large biogas programs. We also have a few systems in Cambodia, some systems in Ghana, some systems in... We've just shipped this morning, just before you arrived, 45 systems have gone to Mali.
Wow.
So we are going next week to go and train
like
them.
everywhere,
Yeah.
worldwide, basically.
Yeah, we are actually international.
Oh, wow.
We've got one in Brazil, we've got one in, I think there's 2 in America.
And you started them.
Yes.
I mean, they're you're
Yes,
the
design,
founder.
The design is my design, yes. Yes.
Okay, wow.
Yeah. God gave us teeth, so we chew before we swallow.
Of course.
So that's what we've done. We've just chewed up all of that marketplace waste.
Yeah.
We've got a nice swill, which is, as you saw me feeding water into the system, we now have the correct texture,
Yeah.
and we just pour it down the throat and into the system.
Okay.
And that's it.
For the cow dung, you don't need to do this though.
No, cow dung is already smooth,
Yeah.
so you just need to mix it with water
Okay.
and then pour it in.
When I get the package, do I get this as well?
No,
Okay.
no, these come
This
extra.
one. Okay.
These are more for if you're going to be dealing with
Market waste.
yes.
Okay.
market waste and stuff that needs chopping. And
Ah, all right.
so normally you can chop it with a panga,
Yeah.
you can what have you, but what we'll demonstrate is that once you get to a certain level, then you can have a generator running off the biogas that provides the electricity to run this. So it's all in a loop.
Yeah.
Everything is
Yeah.
together. So
Okay.
it makes sense to
have
instead of
this.
spending hours trying to chop up what you saw me grinding in a few minutes, you know, it will really
Make work
improve
easier.
efficiency, exactly, and time management. So it's like a tube, but it's pillow shaped, and as you can see, there's no construction. There's no digging
Oh.
underneath.
Yeah.
So the only important part of the installation is actually the ground
Leveling.
must be 100% level. So you were talking
Oh.
earlier about
Yeah,
how to
you
make
can-
money from your
yes,
system.
Yes.
You can sell the fertilizer. It's very valuable
Okay.
fertilizer.
Okay.
And notice there's no smell.
Yeah. Amazing.
There's nothing in there to rot. We say
Okay.
imeva. There's nothing left to
yeah,
ferment or
yeah.
break down.
This technology by Flexi Biogas in partnership with International Fund for Agricultural Development IFAD has many advantages, with cooking gas being the main benefit. It is one of the best ways of saving energy and the cheapest. The gas is also non-poisonous, just in case you forget to switch it off. This technology has many other benefits, including providing electrical energy, powering generators, and farmers are encouraged to use the system.
Now we've learned that you can turn your kitchen waste, your market waste into good biogas and rich organic fertilizer. Well, I have been your host, Wairimu Mbogwa. Join me next time, same time, different location.
Thank you.